And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, smAshomash.com. And we're looking at the solar colorized magnetogram, Sunspot 2827 up here in the north, 2828 down here in the south, about to lose its name, and 2829 perhaps rising over the southeastern limb. Let's see if it's a sunspot. And we did see umbre when we did the show prep today. Not showing up in the intensity gram animation. So this animation, just the intensity gram here. Sunspot 2827 does harbor the type of magnetic fields required for producing significant flares, although we will see the Earth-facing quiet coming into effect over the next about 36 hours. At the same time, we are also awaiting the arrival of a coronal mass ejection. So look for that in the solar wind data today. We're expecting to see that happen. Something like midday today would be my guess. NOAA is expecting it late in the day into early tomorrow. Here's another view of the closest star. It's the colorized magnetogram composite with 171 angstroms ionized iron. And you can still see all of those magnetic loops created by Sunspot 2824 as it sets over the northwestern limb. And this area down here, if it is a sunspot, it's a pretty small umbra so far. So let's take a look at what's been going on from the viewpoint of Lagrange 5 and Lagrange 1. Stereo A is located at Lagrangian point 5, and we do see some ejecta coming out of the sun here. Some of it is a bit in the Earth-facing vicinity, but it's quite slow moving. It's not your average coronal mass ejection. It's just like a stream coming out. And you can see here over at Lagrangian point 1, that's the Soho-Lasco C3 there. Lagrange point 1 here located between the Earth and Sun. About 1/93rd the distance from the Earth to the Sun, about 1,000,000 miles away. So it looks like most of the ejecta here is slated to miss the Earth to the south. Some is sort of on the way here, but it's just slow moving. It's not going to show up as much of a signal in any solar wind data or anything like that. Keep in mind this could suddenly eject, and if it does, we'll cover it. And again, Stereo A is located here at Lagrangian point 5. The Soho-Lasco C3 is located at Lagrangian point 1. Here's a diagram of the solar system. We'll animate this. There's where things will be in 1 week as we approach another new moon. And here's a star chart. You may see Jupiter, Saturn, and the moon up near the apex of the ecliptic if you've got a clear sky in the morning. And the 10.7 centimeter radio flux, also known as the 2,800 megahertz radio flux, at 82 at this point. Here's a 1-year chart of that as we watch the progression of cycle 25. So 82 is the new number for the radio flux, the output of the upper chromosphere and lower corona in radio frequency. NOAA forecasting the arrival of the coronal mass ejection to happen at about 1500 Universal Time, so 3 p.m. Universal Time is the NOAA forecast, and it looks like they're expecting about 18 hours of coronal mass ejection, as it was a slow and sort of an ongoing coronal mass ejection. It didn't happen all at once, folks. So anyway, that's the NOAA breakdown. You can find that yourself on the NASA Space Weather Enthusiast Dashboard, part of the Space Weather Prediction Center. Next, we're going to look at global seismicity here, and here's the 90-day earthquake graph, the bar graph from volcano discovery. And it looks like we saw about 3 5 magnitude earthquakes here, several 4 magnitude quakes, including some in China, and one in the mid-Atlantic ridge. Let's check the list on USGS. We'll just let this scroll, noting anything out of the ordinary. And before we continue on, I would notice this. Late yesterday, we did see a South Carolina quake at a 2.6 magnitude, a little tremor there happening in South Carolina. That mid-Atlantic ridge quake was a 5.0 magnitude. There was a 5.3. I think that may have been the largest of the past 24 near Japan. Also a deep quake near the Philippines. A deep quake near the Fiji Islands in the deep quake capital of the planet, Oceania. Also, the Kuril Islands saw a deep quake as we did show prep. That's not the Kuril Islands, that's near Kamchatka. Kurilsk, Russia, south of the Kamchatka Peninsula there, 4.6 magnitude. VolcanoDiscovery.com has not been updating its Volcanoes Today page, although Seismicity in the Aleutian Islands, despite being downgraded to a aviation level yellow, volcanic alert level yellow, it's produced a 5,000 plume of ash yesterday. Revenador also appears to be erupting in an explosive fashion and producing a 15,000 foot ash plume. At least on yesterday's data, I think Volcano Discovery may be on vacation. Don't let that be an excuse to decide to pole vault the caldera. If you know of a volcanic caldera, don't pole vault it. Maybe if it's inactive, but certainly don't pole vault an active caldera. This public service message brought to you at massive personal risk and expense from smAsho.com. We did see a C-class flare happen here just a few hours before we made the video. That was at 4:30 Universal Time. Little C-class flare happening there, most likely from Sunspot 2827. And we don't see any spikes in the ghost proton flux. No surprise there. No major coronal mass ejections headed our way. Just a glancing blow, which we're expecting pretty much any moment now. Certainly in the next few hours, we would expect to see the onset of that coronal mass ejection. Here's the GOES magnetometer over the past 3 days, and we're expecting some additional spiky readings in this as we are right in the mode of moving to the other polarity. Current sheet, Earth is about to snap into a South Pole current sheet, and here is a diagram of that. This data is from 51 ground-based magnetometers, as well as magnetometers here at Lagrange point 5 on stereo A. And stereo B at Lagrange point 4. And you can see the coming of that South Pole oriented current sheet. Earth is just about to snap into that at the same, basically the same time that the coronal mass ejection is arriving. It could create some unexpected effects, certainly. Here's another view of the same data. Here it's the line of sight ecliptic plane field plot. And you can see that red colored South Pole current sheet on the way. Expecting that at any moment, really. Also, we do see some coronal holes. So yesterday's daily space weather video was included in the title at least, Coronal Hole Drought. And we do see some now. So here are some South Pole oriented coronal holes stretching up toward the equator. And if you want to see the way this solar cycle's magnetic environment compares to 11 years ago, check yesterday's daily space weather video. We talked about it briefly. So Sunspot 2827, again, still does contain the type of fields that would be required to produce significant solar flares, although the likelihood does drop a little bit with the Earth facing quiet. Sunspot 2828 has degraded, and 2829 may or may not be a sunspot. We'll let you know by the end of the video. Global geomagnetism currently quite calm here at a KP of 1. Current planetary KP index only at 1. Let's take a look at the real-time solar wind. And we did see what looks like a brief coronal mass ejection pulse right here. Very brief. Lasting only about 15 minutes. But we see this signal here in the plasma temperature, the speed, as well as the density. So we see this signal happening here all at the same time. A minor shift in the phi angle, a minor shift in the density, a more significant shift in the solar wind speed and the temperature. So that looks like a little bit of a minor pulse of coronal mass ejection there. Current solar wind conditions are only 311 311 kilometers per second for the solar wind speed. Solar wind density 5.73 protons per cubic centimeter. A diffuse solar wind indeed, and expect to see a significant uptick, especially in the density, as the coronal mass ejection arrives. So here's the magnetohydrodynamic pressure over the past 4 hours. It's our geospace magnetosphere movie. We look at it daily, and if you're wondering where the daily space weather videos came from, it's because I noticed lots of YouTube channels covering small aspects of the space weather, and over a period of a few months we determined what we wanted to cover. Since nobody else was doing it, and who knew it would create all kinds of insights into things like the solar cycles and other stuff about cosmology. We weren't expecting it, but you have to go where the data leads. Here are 4 hours of data on geospace delta B. It's ground magnetic perturbations coming a little closer to home here. Looking at perturbations on the ground level, magnetic perturbations over the last 4 hours. Today's cosmology segment's going to be very short. Let's blast through it. By the way, we also are on Twitch. Thanks to our YouTube subscribers. And if you're new here, don't forget to press subscribe so you can see when we produce a video. We're also on BitChute. And we are counting down to the solstice. We will be streaming live at this moment, 11:32 p.m. in 9 seconds. We'll be doing a live stream for the solstice, so join us for that. Also check out our own website and welcome the Neo Renaissance. SMASHOMASH.com, SMASHOMASH.org will redirect you. Today's random number is 442, which is a type of AM Canum Venaticorum star, which is a rare type of cataclysmic variable star with an extremely low hydrogen content and an extremely short periodicity. So this is something like two very hot blue stars orbiting each other at a periodicity of like an hour. So one or both of those stars moving at relativistic speeds in order to complete those orbits in that short period of time. And we're going to show you a visualization in the X-ray output of one of these specific type of catastrophic variables. It's the N type, catastrophic variable type N. So periods of 10 minutes to an hour with these orbiting stars. A quite violent environment indeed at those. So here is one of those catastrophic variables. And this is entry number 442 on the Neil Gorell Swift Bat X-ray Observatory. So this is RSCVN on the Neil Gorell Swift Bat X-ray Observatory, the Burst Alert Telescope, and there's the X-ray output over the past 16 years. It looks like it actually just came out of a dormant state here, folks. For some reason, we're not seeing any data here over the past year. Although over the past 30 days we are seeing data, so that's interesting. Perhaps warranting further research. And here's a little bit of visual analysis of it. This is the DSS-2, which is optical range. Let's take a look at pan-stars. Some pretty high-resolution imagery there on pan-stars, as well as some likely artifacts. And there it is in infrared light on the 2-mass. Here's Galax. That's what we actually started out as. And there is the Chandra. It's not showing up on the Chandra. I thought it was on the Chandra. All right, anyway, there it is in blue light. And here it is in red light. Again, it's entry number 442 on the Neil Garrels, which monitors lots of different X-ray sources. Today's astronomy photo of the day is a destroyed image of the Orion Nebula, thanks to the Starlink satellites. Yes, SpaceX's Starlink satellites ruining a lovely image of the Orion Nebula. Thanks, Elon Musk. I don't know why you're such a douchebag. You just are a complete and total moronic douchebag. Next, looking at charging environments. Are there electrons charging up satellites right now? Well, no, is the short answer. Here's a one-year chart of the electron flux. You can find this graph at solon.info/solar. Here's a 3-day chart. And we wouldn't be surprised to see this crater when the coronal mass ejection arrives. Currently in a moderate range. And NOAA is expecting a small downtick here as well. No argument there on the forecast model for electrons. Next, looking at the total air column. So this is the total electron content for the entire air column, all the way up to the extremely high altitude of your geosynchronous GPS satellite down to your handset, showing you the position of likely errors in your GPS. We're seeing a little bit of anomalous nighttime electron blobs here. Fairly incoherent Van Allen belts, actually, right now. Normally, you would see very minimal GPS errors, even around the equator at nighttime. Currently, some errors happening despite nighttime. So here's a diagram of the Van Allen belts. If you need to pause the video, feel free. Here's another diagram of the atmosphere. We show this to show where the F layer is located at about 300 kilometers. Here's an animation of that. Just one slice of the atmosphere, the F ionosphere layer, in vibrational frequency in megahertz, or millions of vibrations per second. And let us know in the comments if you think you're seeing anomalies in the ionosphere. It's looking fairly normal to me. And this is one of those data sets that you will not have any insight into unless you watch the videos regularly. Anyway, here's the latest image from 8:45 Universal Time, looking highly discharged here. And folks, the ionosphere layer is in many ways the bridge between space and Earth, as it's where we see it's where we see a lot of ions. So there are a lot of chemical reactions happening there, as well as a lot of vibration. And that's why we study it in megahertz. Next, we're going to do a meteorology segment. And let's invite Twitch for that. And for the rest of you space weather viewers, here comes bonus features. Today's bonus features are going to start out with the L-Tide hydrogen alpha imagery from the ground-based solar observatory. We still see significant filaments here on the sun in the south. This is the part that is currently ejecting. We also see filaments up here. Don't be surprised to see some solar flares out of Sunspot 2827. Let's see if Sunspot 2829 is going to be a thing. There's 2827. And there's the magnetogram of that. You can see it is still a beta gamma delta class sunspot. And let's press refresh here to make sure we have the latest imagery. So here's the magnetogram. This new rising region is a sunspot. So you can see that dark umbra there. And here's the full disk view. So again, there's a coronal mass ejection on the way, folks. Thanks to our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com/smashomash. As without our patrons, the likelihood that these videos would still exist and be publicly visible is much lower. Again, patreon.com/smashomash is the URL. If you want the earliest alerts, multimedia, and all kinds of other perks, become a patron. And next we've got some more imagery here. We're going to show you the 335 angstroms SDO view, as well as a composite image of the sun. Just let me get those loaded. So here's 335 angstroms from the Solar Dynamics Observatory. This is one of the many ionized spectral states of iron. The UV emission from ionized iron. And here's another view including ionized iron in two different ionized states, as well as ionized helium. So 211, 304, and 171 angstroms. And we'll zoom in a little bit here to close things out. Thanks for tuning in to the Daily Space Weather. And may that solar wind be at your back.